Okay, so we are going to cover Unit 6 today. Fairly shorter notes and also lecture and assignment. I'll try to get through it so that way you can work on your lab or start doing that. So we're gonna talk about utilities, some of the tools that some of you have started using in prior sessions, but we're gonna touch on how to be able to use these tools for management purposes, troubleshooting purposes, and if you get into the cybersecurity, these tools are going to be essential. So one of the main utility that you see is going to be ARP. This is for address resolution protocol. It is used to be able to obtain the table that contains IP address and MAC address for the connected systems. So when I'm pulling ARP table on my system, it would be able to show me all the connectivity information between my system and other systems, either locally or non-locally, right? So now ARP can be used on other devices outside of your PCs. You can pull it on some appliances to be able to determine information of which system is connecting to a switch, etc. So to kind of, and in Windows environment, you simply just use ARP-A, and we'll talk a little bit more about this. So as you can see here, right, it's going to give you the interface information. It's going to give you my IP address along with other systems' IP address that I'm connecting to. And in the second column, it shows you the physical address, which is your MAC address that is correlated to each specific systems. Now, if someone is able to access ARP table, they're able to view the information. Not only that, they're able to edit the information. This is stored on RAM for the system. So if you are using your PC and you're looking at ARP and you're looking at all the lists, that table is retained on the memory itself. And so it is cached, right? And it updates as you have more connectivity. Now, the changes in this is someone can edit the ARP table and add in a specific entry that would contain their own IP address and their MAC address. So for an attacker who wants to be able to spoof, right, or use other system information to mask their own, you would see that they would be able to edit the table if they have the access and to be able to create the entry. So in the lab today, you are going to edit your virtual machine ARP table, and you are going to add in an entry, and you would see how easy it is for someone to do that if they have that access level. So in the assignment, we're going to look at specific utility, right? That is prioritized for network connectivity in administration and also in troubleshooting. So for number 1A, Jessica wants to display and modify ARP cache on the system. And so which utility should she use? So she should use ARP table, and the way that you would access it, right? For Windows environment, you would do ARP --A. So that option A allows you to view all content of that table. And so it's going to give you the information like I showed you, right? You would see that it shows you the IP address and the MAC address in parallel. Now, some type of connection is dynamic. That means that it's changing. Some are going to be static. That means that it's added permanently. And then sometime you would be able to see a longer list if there's kind of more connectivity. So that will be what you see. Now, ARP works with additional options, so that's one way that we can view. And to edit, we want to do a -S to set. So if you want to modify your table and add an entry to it, you would type in ARP space -S. And S allows you to set. So at this point, your parameter following the S is going to be an IP address, and next to it would be a MAC address. So once you press enter, then that is going to store it into the cache, and that's how you edit your ARP list. Okay, so we know that -A is to view and -S is to set or enter an entry in the ARP table.
Walked in with late, sorry, but the ARP, were you saying it has to do with how the local network communicates, or?
Yeah,
Okay.
so that's how it's pinpointing your system, right? Because the router uses the IP to bring the traffic to the area of the network, like the zip code, right? We talked about network mask, but the switch is gonna determine which system that is based on the MAC address.
Okay,
Yeah, so it stores all, so if all of these systems are connecting to a switch, that switch would have the information of all of these systems. Now, the first time that you connect, it's gonna create that one entry on the list. And so the switch has that information and your system also has that information. So that way it would correlate. This is the system in the network and this is the physical location of that system. Yeah.
but I think it's on the same topic. I was trying to watch like an informative video on it.
Uh-huh.
They keep mentioning like the IP address or how like I guess how it knows the IP address from within the router or something like.
Yeah, so the router, it basically just look at your network ID. Remember, we talked about which portion of the IP address is the network ID, so it determines that based on your subnet mask. It's kind of like the post office knows what street your house lives in or the area of your house based on your zip code, right? Not necessarily the street, but so it would bring it to that area. So the router brings it to the network. Your switch, its job is to take that and forward it to the area that you need. So yeah, so the MAC address is really used internally to really identify the physical system where that's located. Because if you're looking at a national company, let's say Bank of America, you have multiple offices, right? Even in the same city. So what you see is you would be able to have it routed to a specific part of the network, and then from there, the switch is gonna then pass it to other switches. That's gonna be determining, you know, the ATM machines, the workstations at the branch office, etc. So that MAC address is important, and then also, you know, the switch is then gonna prepare everything for the router to get it in and out of the network ultimately. So your router really brings traffic into the network, right, into that area, but the switch's job is to get it there. So level 2 switch uses MAC address, and that's all it's gonna use to determine like what part of the segment is your system. Okay, now, since we're on that topic, if you look, right, you can see here, we talked about a broadcast address, right? Remember, it ends with 255. This is like a couple weeks back. And with that, in parallel, you see the MAC address. When you see all Fs like this, that's a broadcast address, okay? So that system sends to all, right? So now, how does it know like which IP address is used like IPv6? Or we talked about how it looks at the neighbor. So sometimes you have a system that sends information to all the other system to verify, right, the information for that particular part of the network. And you see the same thing, and this is a complete broadcast address at the bottom here, right? And then you see other addresses in parallel that is usable address, right? That belongs to host, individual system. So you're gonna see every network. So this is my home network, right? And you would see that it has a broadcast address equivalent to RCCD network because I'm home, I'm connected to my 192.168, my wireless router, right? And also when I'm here, I'm connected to the RCCD network. So what you see that these are some of the devices that communicated back and forth in some sense to all, right? Some receives and respond. Now, another way that we can check the status of connectivity is to use netstat. So netstat allows the administrator to gather a system that is currently connecting. You use this to troubleshoot and you use it for analysis. So it's used in multiple ways. I think netstat is, it takes a little bit of time to pull the information, but it does give you some details if you need to outside of Wireshark and other applications. So this utility is commonly used to for us to determine which systems are connected outside of using ping or other utilities. So it gives you options to kind of look at like the overall how your systems are connecting and so on. Now, you simply, right? If you check, and it takes a little bit to kind of pull the information. So as it goes, it's going to give you the local address, the port information for that particular device, right? And then if it's connecting into the WLAN, into the wide area network, the WAN, you would see that it shows, so these are the web-based connections for my system, right? And it tells me that it was established, so that was a successful connection for the device. And so you would see that these are the higher port numbers, so that means that it is using dynamic ports for most part, right? And then on this side, it tells you the protocol. So when you're looking at the column where it says the foreign address, that really represents your destination system, whereas the local address, which is your source system. So this system is communicating with this system, right? And so as I have connection, it continues to build the information and eventually it will give you more details for the analysis portion. Now, if you have a system that is connecting to less, or it has less services, right? Let's just say, or connecting to, maybe one device, you're going to have a shorter list. Okay. Now you see how at the end where it says close wait and time wait, that also means that, it either ends the session or, it stopped the communication and then, or while it's also pending. There might be exchange of information, for example, like I will be able to access a specific website. If it's established, it's connecting, it's giving me the web page, right? It's gonna say that. But then there are systems that are still, see how the domain, it's still having the time wait as I'm still, it's communicating back and forth. So you do see some status that's a little bit different. Okay. So we saw how netstat is for C. Jose is trying to verify host IP and physical connection of his computer. Which utility should he use? So he can use a ping command, which uses ICMP. And when you run the ping, it generates a request, right, to the target address. So here's his IP address. So you can ping using a loopback address if the system is pinging itself, which is the 127.0.0.1. Or if you know the actual address for the system, you can just type that in. So either way, you should get the same response, right? So let me see if it builds this out. Okay, so we can see that I can ping 127.0.0.1, and you can do the same thing on your computer. So in Windows system, as I mentioned in the prior session, it sends 4 packets, right? And if it's successful, you're gonna see the statistic it's sent for and received for. So it basically sends to itself, right? Are you connected? Are you connected? Are you connected? Are you connected 4 times? And if it's connected, right, if it's having live signal, then it's gonna respond. So I have 0 loss. That means my system is 100% connected. Now, you do see if you have network performance issues and if the connection is disrupted, or let's say that it is connecting, but there's a delay, it would also show you that. Sometimes you will have not 100% because you might have some degradation in system signal. So for example, like it might take a long time to get there, right? It might not be able to respond because we have a time to live, remember? Right? If it doesn't meet that window, and I think we talked about this last time, then you do have some loss in that, and you can check that with performance on how you can upgrade sometime cable, sometimes, you know, any appliances in between to be able to pass the traffic. Okay, so that's C. We're using ping. And then what we can do is we can answer D. A technician needs to troubleshoot a conflict on NetBIOS for 2 systems on the network. Which utility the technician used? Always remember that we cannot have the same IP address for 2 systems. That creates a network conflict. We cannot have the same host name for 2 systems. That creates the conflict. Just like, you know, how you have a driver license number that is specific to you, not another individual, right? So if you have a conflict naming the system the same, right, you have to be able to check and make sure. So a way that we can check our system name is we are going to do a host name. And this is the same in Windows as it is in Linux. And you would see the same thing with ping, right? Some commands are slightly different in Linux compared to Windows, like ipconfig in Windows, but IP address in Linux. And you saw this in the prior lab. So now I would do this to verify the host name for 2 systems. If it's exactly matching, I have to rename the system name. So who knows how to rename your system on Windows? Anybody knows? So in settings, you can go through control panel. You know that you can access your system category in settings. And then if you scroll down and go to about your system, it gives you the general specification for your system, right? On the right, here you can see that you can click this button where it says rename your PC. So again, I just simply open up my settings by searching for it. And it takes you to a screen like this, right? And this is on the client system. So it's like Windows 10 or 11. You click on system option and you scroll down and it's under about. And on the right-hand side, you can click rename. And once you type in the new name, it will prompt you to restart. It won't refresh until you restart your system. Another way that you can rename is, since you're on this page, you're going to click Advanced System Settings. Traditionally, this is how you do it in Windows 7 and prior. You would go to Control Panel, System, and then Advanced Settings. So it still has the legacy look. So the property sheet comes up for your system and your computer name is here. So I can put in a description, right? I can also use this. I click change, and this is where I would be able to change my computer name. And then this is also where I would be able to join my system to a network, right? So that is in advanced settings under your system settings. And you can also search for system settings on the Windows search bar. But so interviewers for IT companies, they like to ask these type of questions, right? Because commonly, when you join a system to a domain, that might be like a technician type of task. Any questions? Okay, so now nbtstat, that is a tool specifically for NetBIOS, and in Windows environment, it is very common that you still using NetBIOS with the server. So it's a way that system can be connecting using names instead of IP address. They can be identified in the network. And we do that for the backward compatibility with the prior OSs. And so this is how Microsoft has transitioned over time to make sure that the operating system is compatible for the network capability for your system. Now for E, Christina is looking to connect remotely to the system's terminal for troubleshooting. Which utility should she use? I don't recommend using Telnet because it has transparency in your message. Your communication is not protected. That means that everything in plain text can be captured and seen. So if they're running network monitoring tools like Wireshark, they would be able to capture your packet and be able to analyze what you're sending. Now, Telnet can be used to connect from my system to a switch to another PC, and it would open up a terminal, which is what you see command line. And I will be able to send direct message to it. I also can use it to configure, right? If I have the appropriate access to the other system for configuration. So when we do the lab for the switch, you would see that we would use PuTTY and we can directly connect to it. Now, ideally, you should be using SSH, and SSH works on Windows and Linux. It's more commonly found in Linux prior to some of the more modern OSs, but what you see is SSH works for all OSs. So it's a way that we can communicate between, we set up communication between the two systems directly without having, with more security. So it provides an encrypted communication channel to be able to set it up. So when you set up SSH, it requires you to generate an encryption key, and that key would allow you to access the other system. Same thing with the other system. So you would have to be able to generate the key on both ends. And it uses PKI. So some of you are taking CIS-40A public key infrastructure. That means that it has a public key and a private key. And so the public key is used to encrypt, the private key is used to decrypt, vice versa, right? So you cannot open the session without having the specific key. So that's the point is, it's kind of like you lock your door, right? With two keys, right? The one of the key you send out to the other person saying that I locked the door, but they cannot open the door without having a second key. So that means that that private key is only going to be kept to that particular system that is encrypting. So now Telnet was very commonly used in the 90s because that was the technology that they have. And then SSH secure shell is what you should be using. Okay. So for 2, it talks about when does ARP broadcast occur. When your system IP and MAC address entry is not stored. That means that when a brand new system, let's say that you have a desktop PC and you just install the operating system on it and you turn it on and it doesn't have any connectivity yet. Remember how you can add wireless connection to it or wired connection to it. So at this time, what it does is it's going to ask everybody nearby, right? Like it's going to be determined by the neighbor, and it sends out, and it's going to say, here I am, right? I need, and it's going to try to communicate with the DHCP server. So When it doesn't have an IP address and a MAC address, it would do that. But your system out of the box, your network adapter actually has a MAC address. So you don't want a lot of broadcasts in the network because broadcasts just create, it reduces your network bandwidth. So ideally, we know that some systems broadcast, right? But you don't want all systems to broadcast because then it's just so it's kind of like you walking into the room and everybody is talking to everybody else like out loud all the time. It's very noisy. It's very hard to hear the conversation. So in the network environment, it's like that. If you're using a lot of broadcast traffic, you are going to have reduction in bandwidth. Okay. For 3, why does a system store ARP information as a cache? Basically, it's a way that it can quickly reference the addresses, right? It stores it on the table, so that way if it reconnects to that same system again, it just goes to the cache or the RAM and it will find the information so it doesn't have to reestablish it all over again. So the step is to really reduce, right, the amount of time in response for your system. So the address resolution process is then the time is reduced, and it also reduces your network bandwidth usage. Like I mentioned before, right, it has to initially broadcast. So if once it's established, it stores that information, it can quickly go back to that information and resolve the address, so that way it reduces the time for communication. And it won't take up your network bandwidth. So, bless you. So ARP communication, there's a huge section on there. You can see, right, the machine A initially, it sends to everybody on that segment, right? And it says that here I am, I'm connecting, and this is my information. And then that information is then stored to the device that is forwarding the traffic to the destination system. Now, if it's trying to connect to this system, like for example, this is system B, right? It's going to wait for the response. And so the middle devices, like your appliances, and also store the communication back and forth in RAM. So attacker would then, if they want to impersonate the system, they would then need to, one, right, access the ARP table here, the switch table. And if they're able to do that, they can add their own or, look at who's connecting and take on the IP address. So people say, oh, it's easy, spoof the MAC and the IP address. It's actually in a network environment. If you protect your appliances and you know how the transition works, it's a lot harder than you think because you have to get in past the firewall. Once you get to the segment, you have to pass those appliances. If they have network intrusion detection system, it's going to sound off the alarm. So you got to disable those, right? So you kind of have to plan. It's kind of like a robber robbing the bank. They have to pass through the security guy at the gate, right? And then once they're in the bank, they have to pass the teller. Then once they pass the teller, they have to pass the vault, right? So there's many steps that's involved in getting from externally into the network, if you think about that, right? So if you have the appropriate protection, it just slows them down and hopefully we'll be able to detect it before they get to wherever it's supposed to be. Okay, so what you see is there are 4 types of your ARP requests. You have ARP requests that is IP to MAC, right? And then the system would reply back. And then your reverse ARP, your RARP, those are MAC to IP. That's the opposite, right? So it's going to correlate the MAC address to the IP address. That's a reverse ARP. And it talks about that later on. Now, you saw on my table, I have static entry. These are added with the utility manually. And then you do have some dynamic entry. So the dynamic entry, it has a time that it would stay on to the table. And eventually those will get updated. They don't stay there permanently, whereas the static entry, they stay there permanently. So when you look at the ARC table today, look at those carefully, right? So that way you can determine the difference. And then it talks about the age here. So your initial cache is about 2 minutes for the Windows entry. And then if you have it dynamic, it would then adjust the size and automatically update depending on how often it communicates. Okay. So now how can I find this information? Your Windows system have a registry. It's a database that is maintaining to be able to identify information for hardware and software purposes for the operating system. So our cache life information, and it's under TCP IP parameters, it's stored into the registry. And so the lifetime of it is 120 seconds, which is 2 minutes. You saw that from the previous section. And this is how you get there. Now, normally regular users should not be able to access that kind of information, right? So if you're the system admin, you should be able to find that kind of information. Okay, and then the reverse ARP, like I mentioned, that's MAC to IP address, where ARP is IP address to MAC. Okay, any question regarding address resolution protocol? Okay, you see it again if you're taking security classes. And then in the next section, it talks about IP config. Now, I know you've seen IP config, so I'll type that in if I do an IP config only, right? It's going to give me a briefer information. It tells me if I'm connected to a network, my version 4 address, if I have a version 6 address, and you see that there's a link local IP version 6 address, and then my default gateway and my subnet mask, okay? Now, if you can add an option to your IP config, so when I need to get rid of my IP address, I would do an IP config space/release. So you would add the /release after IP config, and this would take the assigned IP, right, and flush it. And then after that, the next step is to do IP config/renew. It's going to go back to the server and obtain another IP address. Now, often you would see that if that address is given back, right, it might release the same IP address again, right? But we would do this if you are having issues with connection for your system. So you would release the address to see if it's connected, and then you would renew the address for, sorry, let me, why is it so far separated? Okay, I must have moved it from my Monday class. All right. So for number 4, it says, what's the lifetime of ARP? I think we just touched on that. By default for Windows, it's 120 seconds or 2 minutes. If it is reused within the 2 minutes, it will remain on the table for 10 minutes. So those are the dynamic entry that we mentioned. But if it's not reused in the 2 minutes, right, it becomes stale, and eventually sometimes you would see that it is stale, and then it would then flush that from the memory. Otherwise, you will exceed your buffer size, right, your cache size. So they do this so that way your system can be controlling the resources that it's using, instead of having a huge ARC table, right, that just keep on growing, and it would take up a lot of RAM space. And then for 5, the difference between reverse ARP and ARP is that reverse ARP translates MAC address to IP. It correlates MAC to IP. And ARP translates IP address to MAC. Just like how when you do a reverse lookup of someone, you can look up by phone number to their name, right? And regular lookup is name to phone number. Same thing, right? So you would have reverse that it would associate the MAC address to the IP, and the regular ARP, your address resolution protocol, it translates IP address to MAC. So we talked about IP config release. So what commands do you use to remove an assigned IP address from the system and obtain a new IP address from the DHCP server? You would start with IP config space/release, and that would flush the IP address that was given to your system, so it removes it. And then you do IP config space/renew. You would then send that request to the DHCP server again. Remember how before we took a Friday off, right? The week before we did a DHCP configuration where we create a scope. And so using that scope, it's going to give you an IP address. Now, like I said, sometimes you're gonna get the same IP, okay? Because that's the next available IP that you just gave back. And also the lease, remember how you set up for 90 days or 60 days? Well, it's checking that lease and it's saying, oh, you know what? That's the one that's available for the next 90 days. So you're gonna get the same thing, okay? Or sometimes you get a different IP address because it's given that IP address to something else. So you do see sometimes that you get the same one. But we do this, like I said, if you're having connectivity problem. So for example, you get a service ticket and it tells you that, so and so at system A is not able to connect to the domain or the network, right? So what you do is when you go to that system, you need to, number one, check the cable connectivity or the wireless signal connectivity. I normally reboot the system because once you reboot, sometime it also re-obtain a new IP address. But if you don't want to reboot because they might be running some local application and they don't want to lose their data, then you have to open the command prompt for Windows, and then you do a release and renew. But I highly recommend the reboot because the reboot refresh everything, and you're gonna get a better connectivity information for your system. All right. Okay, so now I'm gonna move 6 down. Okay, so in Linux, you would see that sometimes you would use commands that are similar or different to Windows. In the notes, it talks about ifconfig. Some textbooks still refer to it, but the network package for that command is deprecated. So when we say deprecated in Linux, that means that it's no longer used. They have created a new package, and you did this in the lab for the Kali Linux when you set the static IP, right? You use IP space address as a command. ifconfig is no longer used in most distros. So if you type in ifconfig, command line is going to tell you that it doesn't know the command and then even if you try to install the packages, that package is no longer supported by the developers. So you would see that it's common with Kali, it's common with using Raspberry Pi. So the Debian-based Ubuntu, a lot of the distro, even Mint, right? They moved away from using ifconfig. So that command is, if you use an old Linux system, like if you have an old Red Hat server, that might work, okay? But you rarely see, a lot of the time they push the updates for Linux because otherwise software won't work. Now, if you have a Linux system, let's say I installed Ubuntu and I want to obtain an IP address. Remember how in Windows we have a review with ifconfig? In Linux, you do a DH client. But like I said, The best command that you're gonna use is called reboot. So you type reboot, press enter, when it restarts, likely that it's gonna obtain the new information. But check to see if it has static IP. Okay, so when you do the lab today, I will walk you through on how to take your virtual machine out of the static IP and make it a DHCP client. Because when I created that virtual machine, I had put in an IP address for it. So that way you will be able to see more details when you're doing PowerShell. Okay, now if you're using ipconfig, you can also fix DNS problem. So in order to join a domain, you have to see a domain, okay? Like what you saw on my configuration, I am part of the RCCD network because my system is connecting to the network. So if you want to view DNS resolver information, right, so DNS is for domain name system. It is a way that we can use a service to correlate domain name to IP address. And that's how it's able to identify which domain that you're using. As human, we always like text, so we have to use a system to convert the text to an address. You don't go around and tell people, visit this domain, right? 14.6.8.11, or even IPv6 is worse, right? You have to say a bunch of numbers. So we just say, oh, my domain is mynetwork.net, right? Because it's easier for us. So we create a system called the DNS to be able to do that. And you see DNS is correlated with your web server because hence the URL for fully qualified domain name. Now, in order to see your DNS information for a specific system, you would do an ipconfig /display DNS, and that would retrieve the stored domain information for that system, right? So if I have a system that's joined a specific domain. Now, I told a story that we used to host Cyber Patriot for high school, and the tech wasn't available on the Saturday that the game was happening, so they told me to come and help out, which I did. And when they used the domain, the public domain for the competition, the person who managed that domain had updated the domain, so it lost the DNS connection. So I had to go and check the DNS information for the virtual machine they're using. And then I have to do a flush DNS. So if you have old DNS information, so let's say that my domain used to be mynetwork.net, okay? And then I decided to move my domain to a different host, for example, and I want to rename it to mynetwork1.net. That creates a problem. So you have to flush the DNS information on the system that used to connect to it. And then you would renew the DNS information. So once in a while, when you open your browser and it doesn't open the page and it gives you the error, it tells you to check your DNS, right? Because it's caching the DNS information for that domain and it's not matching. So likely a lot of the time on browser, it might be user error when they type in the URL incorrectly, or if it's on the back end, that means that they rehost it somewhere. But usually they have a redirect. If they don't have a redirect, that's what happens. All right. Ping, we talked about ping before. It uses Internet Control Message Protocol. And, when you have time this weekend, right? Open Wireshark, do a ping on your computer. You're going to see ICMP packet. You're going to see there's requests coming through. And if you ping yourself, your system's going to send response. And in Windows environment, you're going to see 4 packets. Now, if you run this, you can run Wireshark on Kali Linux. It's installed, right? If you use their VM, you're going to see that it's just going to keep giving you packet until you terminate your ping. You have to do a ping count in Linux. Otherwise, it's just going to keep pinging. Okay. So now the command that you would use or the option that you should use with the ping to resolve an IP to a host name is you're going to do a ping -a, right? And so if I name my computer computer A, right, and my computer has an IP address 10.0.38.114, right? And when you do a ping A, it's going to give you the computer name, computer A, and its IP address. And that's a convenient way to kind of associate, quickly how your system is connected as well. So that's a good way. Okay. All right. So for ping information after the DNS right here, you can go to the bottom of page 3. And then let's talk about some of the options and how we will be pinging. So next section, it talks about ping commands specifically. So if you want a certain type of answer, right, you need to put in your option and then the parameter for the option correctly. So for number 11A, when you ping -n, right, and you put the value 10 here, basically that's a packet count. Okay, so if it's gonna send 10 packets to the target IP, and in this case, I'm pinging myself, so it's a loopback address, but you can plug in any target IP there. Let's say you want to ping the gateway, right? It might be 10.0.0.1. So it's gonna do 10 packets that's gonna be sent. So for Windows, you're gonna do a -n and 10. I think for Linux, it's a C for the count, to be able to add the number of packets that you do, but you also have to put in the target IP. Then for 11B, when you're doing a ping-L, this is not an I, it's an L for length, and you put in the value here, this represents the bytes, okay? So you can make your packet a certain length, okay? So the higher the number, the bigger the bytes, the more network bandwidth you're gonna use, right? And some administrator, they would not allow you to ping, and so that can simply done through setting up the firewall and disable the port and the service for ping. Why is that? Because you can ping someone to death, right? That's called Smurf attack. That's an old school attack, and it's a denial of service attack. So you can set up, and when you see a Smurf attack, when you run Wireshark, you're gonna see a huge dump of ICMP packets that's coming through, and they would do thousands. So it's not just like one after the other, right? So the whole point is to reduce the resources, and your system, as it responds, it has to store the request into its RAM. So if you ping a server 10,000 times, those 10,000 things are going to be stored, and then it runs out of buffer. So you can do a length, and it's 128 bytes. Okay, and then your target IP. Then you can do an option T. This is going to be until it's terminated, very much like the Linux ping command verbally. So you're gonna just ping until you press Control C. Control C in Windows and Linux actually terminate, cancel the process. C is for cancel. And then lastly, when you do an option K, and a target IP address, this is going to exclude the IP address from the route list. Now, we often do this when we're doing a ping for the range. In ethical hacking class, I normally show them tools that they can ping a group of systems continuously together or scan them. The whole point in that is to, sometimes you need to assess a segment where you don't want to just manually do one IP at a time. So you can also have an option to exclude certain IP address that you want to not send that service to. Question? Okay. Now, if you're using IP version 6, you can just simply add the 6, and then the IP address that is version 6 in following. So it uses the ICMP for the version 6. Now in Linux, you don't do a -6, you just type the 6 next to the ping command, and that it would know that it is for IP address version 6. So if you're using when you're using ping and receiving reply timeout message, right? And then you try to modify the timeout value with an option W and resend it to get the host to reply. You still get reply timeout. So what's wrong with your network, right? The way that we use ping is we can use it to check our network performance. So your packets is just delayed, okay? It's kind of like, this is the analogy I used on Monday. It's kind of like, you know, how FedEx tells you you're supposed to receive package on Monday at 3 p.m. and you wait and nothing arrives, okay? That happens a lot around here, right? And you check the status, it says it's there, but it's not there, right? So in this case, it's supposed to arrive, but it's just missed the window. So now the packets are arriving, but it's timing out before the 4 seconds window. So there is a bandwidth problem, or what we call that is a delay in the network. Is the term for that is latency, okay, in your network connection. So that means that there might be, sometimes if you have a lot of security filter, that can create the problem. Sometimes you have dying cables, that can be a problem, or dying systems, that can be a problem. So if you become a network analyst or an engineer, you have to find out, like, how can I upgrade this? And we have to identify where the problems is. So if you have an aging network, right? And so, you know, so the transit in between is where we check. Why is it giving us the delay problem, right? Or sometimes it might be occupied with other things. So, okay. Now the type of ICMP messages for echo request and echo reply, right? It sends a request to receive a reply. And we talked about this in the prior week. This is the type, right? The 8 and the 0 here. So when it receives, when you look at it, it's going to be, this type is for the request. It's just the number that they use, a numerical value that represents a request, and the 0 represents the reply. Okay. I think I showed you that on the notes last time with the table. So ICMP is slightly different than some of the other type of protocols and services. Type and code. Okay, so I'm gonna move 13 down because some of you might be still typing those. Now, a cool tool that you can use, and I don't know how many times I use HPing. I love it, right? You would see that this is used in security and network area. You can go to their website to be able to obtain the tools. Some version of Linux comes with it, like Kali. So you can do custom packets to the host. We do this for risk analysis. So now there are other tools that attackers use or ethical hackers use to be able to stuff a packet, modify the packet with different things, right, for different purposes. But HPing2 specifically allows you to send custom packet using ping. We saw how in Windows we can add in additional bytes, right? The sizes, but HPing does a little more. Okay. So if you want to determine the number of network routers in between the source and the destination, what utility you use trace RT in Windows, and you type trace RT, one word, And then for Linux, you use trace route. You type out the entire trace route in one word. Okay, so when you use trace RT, you simply put in the domain name, not without the www dot for the web servers. So what that does is the DNS actually gives me, the DNS service gives me the domain to the IP right here. So technically it traces the route to this IP address. And you're gonna see that the traffic is actually slower. It's kind of like I put a camera on your car and I ask you to drive from home to work. And every street that you turn on or, that you stop at, right, it's gonna report back to me. The camera is gonna report the information back to me. So we just basically follow the traffic and each of the hop represents the router that it crosses. Now, in Windows, it's gonna give you the maximum of 30 hops. Sometimes most of the time you're gonna see less unless you are sending traffic in far distance. And so it's gonna be from leaving my gateway, getting through the networks, and then going into the service provider, and then eventually the public network. And when it gets here, you would see the destination is at the 9th hop. And this is Google. This is the data center for Google for this region. Okay. So normally they house their stuff, they would have like network traffic that's being passed, but the data is backed up on the East Coast. If you ever go to like LA, Wilshire, that whole section, you see a lot of tall rise. Some of the tall rise contain huge data centers and different floors. So you see their network right there. Okay, so we talked about trace route. And when you're doing trace route for version 6, if they're using version 6, most of your public domain are still on version 4, right? We still haven't fully transitioned. You can try this. It's going to come back and says it's not going. So if the DNS is not configured, and also the web server that's responding for this domain is not configured with version 6, you won't get a response. So you can do a trace RT in Windows -6, and it's going to look at the target. But ultimately, the domain name here, right, that is just tied to an IP address. So it would plug in the IP address there. Okay, so we touched on the type for echo request and echo reply for ping. HPing2, I put hping.org for you. So if you want to check out that tool, you can. This is often used for a lot of things in security, right? Like firewall testing. You can use it to check how good is your firewall. You can use it for network testing, along with if you're doing reconnaissance for ethical hacking. This is going to give you OS fingerprinting. So when we do fingerprinting, that just means that we're obtaining OS versions and software versions. So if your target is a web server, it's going to tell you, like, is it running Linux or Windows? Possibly what releases, if the tool is good. And then it's also going to tell you the agents. So if they're running like Apache or, so if you're doing like a Windows web server, it will tell you IIS compared to Apache Linux or NGINX, which is like the software that you use to host web for certain OS. Okay, and then trace RT information is here. Know that you can add switches to it. So what happens if I don't know the options, right? You can run a command and then you can do a help. Or I'm sorry, maybe a -H. Maybe they don't do that anymore on the Windows. But Some command will allow you to access the help option. Now in Linux, you would be able to do I'm curious. I have to investigate this a little more because in the older version, yeah, it doesn't allow you to do this anymore. But in Linux, you can use the command to read the manual or the man pages for a specific tool or commands. And then they do well with the documentation too. So yeah, and if you do traceroute -H in traceroute, it's actually for the hop. So you have to put in specific information for that router, or those routers. But some command you can also have the help option. Let me check something real quick. Yeah, so ipconfig takes a help option to the back. So if you don't know how to use ipconfig, you do ipconfig. Let me pull this up. /help, and then it gives you the summary, some of the commands that are common to that. You don't see display DNS and the others, right? It gives you like a little tip on, and then the description of those commands. So some commands with the help option works. And then the others, it doesn't have that. So every tool is a little different. Okay, so the next section is on netstat. So the netstat, as you saw a little bit earlier, it tells you the local address, which is the systems, the source system, and its port information. Likely that you're going to see dynamic port. So the source system would use a door or a window to connect to a certain service protocol. And then the remote address, in Windows, it calls it a foreign address, which is your destination system and its port. Now in Windows, in the current version, you would see like HTTPS that is using port 443, but sometimes you would also see specific port number if it doesn't correlate to like the common protocol services. And then sometimes, and you would see the current state, like established, close wait, time wait, etc. Right? Like, so that will tell you whether it was successfully connected as established, or if it's close wait or time wait. And so that section of your notes, it goes over some information about netstat, and it is a commonly used tool for administration. You can display the network adapter statistics. So the -S here with netstat gives you statistic, right? So you can try, sorry, let me try that for you. So when you do a -S, you're gonna see more numerical information, right? And the throughput also related to your IP address, the echo and replies. These things can be important if you're an analyst. Okay. And then the parameter informations, I try to put as much as I can for you. So the -R is to obtain routing table for netstat. And your routing table also contains like which systems that gets routed to. Now, if you want for UDP, user datagram protocol, so UDP is gonna open as it arrives. There's no three-way handshake for UDP. There's no confirmation on the connection because it's connectionless. So if you want to do the connection status, you would do a netstat-P for protocol, and then you put in the UDP here because that's the protocol that you are researching, right? That you are trying to find information for. So you can do the protocol. Now, if I want TCP, then I put in TCP. Right, you know, most protocols are broken up into two categories, either under the TCP suite or under UDP. Like DNS services under UDP, right? But HTTP is under TCP. Okay, any question on netstat? So practice, right? These things, sometimes you read it once, you might not remember. So if you do it, right, commands. Because sometimes that might be an interview questions or something that you have to do at your job. Okay, 23, how do you run Telnet in Windows PC? I always teach security classes. I've been doing that for a long, long time. And my students are like, you always tell us to disable Telnet and Telnet should not be used, but we don't even know how to run Telnet. It's really simple, right? You open your command prompt and in Windows system, you run telnet.exe, right? Telnet is already an integrated service in most OS. So for Windows, you run it, and because it's Windows, .exe for executable. In Linux, you just do a telnet command and then whichever IP address that you're trying to connect to. So I'm trying to connect to system A that has 10.0.11.111. Type in the IP address, and you know, it doesn't have any password or anything like that required. So if that system is fully open, you would get information on your terminal that you are connecting. And then you can send it a message. You can, you know, now in Windows environment, we normally connect directly to a system using RDP instead of using Telnet, but Telnet uses port 23. So if you want to disable Telnet service, disable port 43 on Windows Firewall. I think it's default disable now because of security reasons, but in the case that it's enabled, you can check port 43. So if you trace, right, or if you monitor the traffic, and if you see port 23 coming up on Wireshark, someone's doing Telnet to one of your systems. So the receiving system opens the door, number 23, okay? So. All right, 25, describe two modes of FTP transfer. FTP servers is still being available. Traditionally, it's used to distribute files. We can upload files to share, we can download files to share. So for example, a company might have an FTP server to be able to share resources amongst their employee. FTP is not too common nowadays, but if Mozilla runs an FTP that's public, so you can also find that. Now, there are two modes. You can have it text-based for ASCII-based file. So if it's like just simple text mode, that means that you can only use text file. Bin for our binary, this is when you would see the server is providing you access to executable. So you can download and upload executable file that is non-ASCII. Those tend to be program files. Bin files are related to programs, and program can be malware, right? Program can be an application. There are so many different things. But now for FTP server, a lot of the time they require you to create a login now. You cannot use anonymous anymore. In my ethical hacking class, I make them put up an FTP server and attack it. Well, they scan it to see if it is it secure or not secure, right? So sometimes you have to do that as part of your job. So you have to kind of know the type of service that's running, and so these things are helpful. So how do you really connect to an FTP server? You can connect to it with an IP address or a domain name, right? Like a URL. You can connect through a browser, through an application. You can also connect to it directly through the terminal if you know an IP address. Public or local, okay? Meaning that it's in the internet, like Mozilla has one, right? Or there are many, well, not too many, but there are some still, I should say some. Okay, so here are some of the commands that you often see with FTP. You can use an FTP-A to log in anonymously. Most server now, right, security advice, we don't allow anonymous login. Back in the day, that was an option. So when you install your FTP services, in Linux system, you can just modify the configuration file, just edit it and allow an anonymous login, then you can anonymously log in. That means that when I go to the website, I type in anonymous as a user, right? And sometimes no password or password is password. Okay. Nowadays, you have secure FTP server. You have to make a user account in order to access it. In access management, you should always make your user become accountable for what they use. So that means that we need to be able to track them. So that means that you have to make them register for an account and then agree to your term and licenses because it's legal issues, right? You know that now tech companies do with a lot of that. So you see this implemented, but this is still an option in the service if you enable it, okay? To disable the automatically login, you just do an FTP-N -N for the option. Okay, for 28, what type of servers allows you to back up router configuration, Cisco network operating systems, and device configuration? You would use a form of FTP server. This is known as a trivial FTP server. It's mostly retaining configuration. You know how when you set up your router at home, it asks you if you want to back up your configuration to a USB, right? And then have it. So in case something happens to it, you can plug in the USB and put everything back. So that way you don't have to reconfigure from scratch. We do that in the network. I actually recommend other form of server for network administration. But this is a form of server where you would have these files that are related to your router configuration, your Cisco devices, iOS, because they come in different versions. It's painfully annoying. You're gonna see that in the future weeks. And then your device configuration, right? The reason why we do that is you might have an enterprise that have thousands and hundreds of these systems. And it helps us automatically pull things in case something happens to it or reset it. But that's one of the server type. So there's telnet information, right? Some example for telnet. And then your FTP is in following on page 7 of your notes. And then I put a link for you to look at on how you can use FTP with Windows systems. If let's say that you manage an FTP server, you want to test it or try to connect to it, there are options. And then trivial FTP server is on page 8. And know that it uses the UDP port 69. Okay. And that's different than your regular FTP server. Next is your DNS. I don't think I added too many questions on the DNS except for the command information. I talked a little bit about this before, but we will configure a DNS for your server. Probably I'm going to switch the lab to server 22 in the future lab. Okay. And then we talked about these commands already. So nslookup is useful. It's definitely if you want to obtain your DNS information. So on command prompt, you just do nslookup. This gives you your DNS information, your server that you are, the domain that you're connecting to for your client system. And you notice that now it becomes an arrow and I don't have the same pop-up anymore. So in order to get out of that, you would just do an exit and it will be back to your command prompt mode. Okay. So if we want to verify if the client system is joined to that domain, you can do an nslookup. Okay, so that will be answer for number 29. What command is used to query DNS server, not the local DNS client cache for the specific system records. And it can be used for troubleshooting why the system is not connecting to other remote system. You would search for its DNS information, and that will be an nslookup. Okay, so a tool that you can see in Linux system is called dig, D-I-G, right? And this is a way that we can obtain information about an IP address of a fully qualified domain name, right? Like google.com, what's the IP address for it? So you would use a dig command and you would type in the URL. And then if you want a summarized version, you would do a plus short. This command would use the option for it is a plus short that gives you a summarized version. Otherwise, you're gonna get a verbose version. In Linux tools, a lot of the time verbose just means that you're gonna get a lot of text information, and that can be very lengthy. So if you want to do a quick lookup information, you need to summarize it. And in most of the Linux tools, right, if it's not default verbose, you do a dash lowercase b, that's gonna give you a verbose output. Okay. So dig is on the bottom of page 9, right? So it's gonna give you similar information to your nslookup. And then I mentioned that you can do a plus short, but I added a table for you in the case that if you need to do this. You know that most of the web servers are Linux servers, right? And then most of your servers don't have UI or graphical user interface, GUI, meaning that I can't click a button, right? When I install the server virtual machine, I actually choose the desktop option, but most of the servers in the world don't. You just have a command line. So you have to learn how to do these commands so that way you know when you're handed the server, you need to know how to use it. Okay, but dig has these options, and you can also reference their documentation. Now, you saw I use host name for my computer name. Sometimes you can also use host. Host will allow you to find information of like your servers. And that can be helpful if you're doing like reconnaissance or even identifying your system in your network. And then it talks about APR or ARP or ARPing. This is a popular tool in Linux using the ping command, and it is helpful. It's using ARP with ping combined. Okay. And then it talks about the MTR. This is used for diagnostic, very similar to what you see with traceroute. But what you have is it's going to be traceroute and ping combined. So you see some tools that have additional capability, or two tools combined into one. Okay, and then your pathping information is on page 11, and that should brings us to some of the next few questions. For 31, the utility that you would use to identify specific type of server on the network, you can do a host command. B, if you want to send multiple ping messages to router between the source and the destination, you would do an NTR. And then C, if you want to manage the route table in almost all systems and appliances, it uses route. And then lastly, 32, what should you do to troubleshoot name resolution problem in a network? And this is a common problem. You might see this on Network Plus certification or even interviews or when you're on the job. So we talked about system connection, we checked physical and so hardware and then software, right? But because the name resolution is really tied to your services, and you would narrow down the services by looking at first, check the local name. Okay? Then to make sure that there's no conflict, then because it's domain name system, you can start navigating from the local system and then expanding to the network. That's how you troubleshoot. So you're gonna go to the DNS and wins. And you saw a little bit of wins when you set up your DHCP last time. You check your host files and the LM host files. DNS also have records or files that it contains for its own domain information. And then the next level is gonna be issuing broadcasts, so that way it would advertise to the rest of the network. And like I said, right, we would limit this for testing purposes, or rarely that we would do broadcasts. And then check your network net BIOS cache, and we saw the nbtstat command at the beginning of the assignment. So you can use that command to check the status of your system for NetBIOS. And NetBIOS resolved by name, right? It relates to your host name. So it seems long, but because we have so many tools, but I just wrap up at 3. So we will be able to do the lab. The lab is fairly short. So before we start the break, if you do the lab and if you started the lab, make sure you give it more RAM and give it more processor, and that's just a practice for all your VMs from now on, right? So 8,000 megabyte or 8 gig at least, and then quad core. And then I'll walk you through on how to be able to set up your dynamic IP. So ideally, if you have a dynamic IP, you won't run into PowerShell error when you get later on to the second part of the lab. I saw this happening to some students on Monday, so that was just like kind of like heads up for me to make sure that I warn you guys. So I'll walk you through that. Okay. So take the time to go through the notes. I think you know, a lot of information is given, right? And then, but you can go through each and you can practice with the commands and the tools. All right, let me stop